Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2009 Calculus BC exam question number 4 from the non-calculator. It is a differential equation reading that the differential equation dy over dx equals 6x squared minus x squared y. We let y equals f of x be the particular solution to this differential equation with an initial condition of f of negative 1 equaling 2. First question off the bat, they say use Euler's method of two steps of equal size, starting at x equals negative 1 to approximate f of 0, and we have to show the work that leads to the answer. So before I even discuss Euler's method, I better write down how to find new y. It's always good to review because we will see that often. New y is always going to be the dy over dx, which is your slope at that moment in time, times your change in x, and then plus your old y. So keep that in mind. We will use this as we make our chart for Euler's method. So our chart will go xy dy over dx and then new y. So since we are starting at x equals negative 1 and we're using two steps of equal size, my next step will be negative 0.5, and then my final step will be 0. They gave us the initial condition, f of negative 1 being 2. dy dx happens when I plug negative 1 comma 2 into dy dx, which is my differential equation above. Once you plug all of that stuff in, you will end up getting the number 4. And then your new y is going to be dy dx, which is 4, times delta x, which is 1/2, and then plus old y, which was 2. That will get you the number 4. Which goes in for your y of negative 0.5. After plugging all the negative 0.5 and 4s back into dy over dx, and I encourage you to pause, that way you can figure it out on your own, you should end up getting 1/2 as your dy dx. And then your dy dx times delta x, whoops, too many strokes there on the 2, delta x plus old y, which is 4, and that's actually going to equal 17 over 4. Now, actually, I probably wouldn't even do this if this is on the day of the AP exam because they don't require you to simplify your answers. So I would just from here write f of 0. F of 0 is approximately equal to either this unsimplified version of the answer or 17 over 4, and then move forward from there. All right. Hopefully that makes a little bit of sense. Moving on to part B, it says at the point negative 1 comma 2, the value of d squared y over dx squared is negative 12. It says find the second degree Taylor polynomial for about x equals negative 1. Okay, so let's go ahead and take a look at what a generalized Taylor polynomial centered at negative 1 would look like. It would be f of negative 1 plus f prime of negative 1 times x minus negative 1 or x plus 1, and then plus f double prime of negative 1 times x plus 1 squared over 2 factorial. Well, we know a lot of these terms. We know f of negative 1 is 2. They told us that at the beginning of the problem. Well, we actually know the value of f of negative 1. How do we know that? Well, we found it out in Euler's method in part A, right? F prime at negative 1 is the dy dx at negative 1. So that ends up becoming a 4. And then x plus 1. And then f double prime of negative 1, we know that too. They told us that. They told us that it was negative 12. So I just punched that in. Negative 12, and he follows along with his standard x buddies. And that is part B. So yeah, so they can throw in some Taylor series into your diff EQs now, so it's kind of neat. So be on the lookout for those. Part C, find the particular solution, y equals f of x to the given differential equation. Okay, so this is back to Calc AB. We've done this so many times. So I think I have enough space, so I think I'll just get ready to rock and roll here. So dy dx is equal to 6x squared minus x squared y. This one's going to be kind of tough to separate the terms on, but I think we can do it. from both terms, they both have an x squared in common, so I think I'll factor that out, giving me x squared and then 6 minus y, and that gives me a clear path towards term separation. So 1 over 6 minus y dy is equal to x squared dx. I'm going to integrate both sides, so I get ln of absolute value of 6 minus y equals x cubed over 3 plus c. Please don't forget, rule chain of the negative. I know you think I was going to forget, but I did not. So from here, make sure you don't forget about that either. So speaking of the negative, let's get rid of him. So I've got ln of absolute value of 6 minus y is equal to negative x cubed over 3 plus c. And you know what? I think I'm going to run out of space here. So give me a second. I'm going to pause real quick, and I'm going to rearrange some stuff. All right, I apologize for that. Turns out I overestimated how much space I actually had. So here we go. Let's keep on moving. So from here, I'm going to go and do my exponential conversion deal. So negative 6 minus y, or absolute value of 6 minus y is equal to e to the negative x cubed over 3 plus c. So we just keep on going, right? This is old hat for us. We've done this so many times in Calc AB that this should be second nature to us all the way. So we get absolute value of 6 minus y equaling c e to the negative x cubed over 3. The absolute value of 6 minus y is plus or minus c, so 6 minus y equals c, because remember, regardless of whether c is a positive constant or a negative constant, it is just a constant. Once I get to here and all the absolute value nonsense is out of there, now I feel comfortable solving for c. So that means that 6 minus 2 is equal to ce to the negative 1/3 over 3. So it looks like, if I solve for c, then that's going to be 4 equals ce to the, that's going to be negative 1, so positive 1/3. If I divide him over, I'm going to get 4 over e to the 1/3 equals c, or I can call him 4e to the negative 1/3. Alright, so how does that help me? Well, it helps me finally because now I can plug it in and solve for c. So I get 6 minus y equaling 4e to the negative 1/3 times e to the negative x cubed over 3. I'm going to combine these e's out, so I get 6 minus y equals 4e to the, I'm going to add the exponents together, so I get negative 1 minus x cubed all over the same 3. And then I'll go and flip-flop my stuff. So I get 6 minus 4e to the negative 1 minus x cubed over 3 equaling y. And there I go. That is how you do this problem. So as always, please leave comments and questions in the questions area or the comments area, and we will see you back for the next episode.